All right, this is part 2 of the Excel tutorial. I'm going to install the data analysis tool pack in case your home installation doesn't have it. So this would be under Excel options, which let me show you that again. So this is the Windows button in Excel 2007, and then this is just right below what you can see. Let's try that again. It's right here down in the bottom. There's Excel options, so I'm going to click that. Now, there's the options, and we want to go to add-ins. And notice I've got analysis tool pack set up as active, so I'm going to go to go here, and now it's showing me the add-ins that I'm currently using. So I'm going to uninstall analysis and solver and click OK. So see right away now they're gone. They've disappeared from my Excel. So yours might look like this. So if I go to add-ins, you may not see any. If you go to data, you may not see anything over here. So if I go to Excel options, add-ins, and then click on, this go here, I'll bring up that dialog, and then you want the analysis tool pack. And if you don't have it, you might as well grab solver because we'll need it later. So analysis and solver, and click OK. And that should bring it up. So if everything goes to plan, then you get this. This is what you'll be using to do your independent T's in your ANOVA. All right, so last time we did a one sample T, and then we did an independent T test, a pooled variance T test. So we assumed the variances were equal. So we would like to test that assumption. So I'm going to go back to my sheet 1, and I've got my 2 columns here of data, food in the city and food in the suburbs. And I want to know whether these have equal variances. So I'm going to select my 2 columns of data here. And now I'm going to switch over to that Excel sheet that came from the course web page. So we just did this one sample T test. So now I'm going to switch over to the Levine's test sheet. So here it says paste your data, group 1 data here, and group 2 data here. So there I go. So I've got my food from the city and food from the suburbs. And so and my results are here. So there's some calculations that go on over here. We transform the data and then perform an ANOVA on the transformed data. None of that is important to you, but these 2 numbers. So we have a test statistic. This is, the bigger this is, the more unequal the variances are. And then here's the significance. So these variances could have been this different based on randomness with a 40% chance. So that's significantly larger than 5%. So we would fail to reject the null hypothesis that these 2 groups have the same variance. So we don't have enough evidence to say the variances are different. So because we can't claim the variances are different, we were justified in our assumption that they are the same. So the pooled variance test was the correct one to run. Let's imagine, though, that it wasn't. So I'm going to flip back to my data here. So now I've got my data, and what if I ran that Levine's test and they weren't equal? Okay, well then I would do my data analysis, but now instead of selecting a 2 sample assuming equal variances, we are going to do 2 sample assuming unequal variances. And select my range 1 and my range 1, and then in the second variable select range 2. So I have the A column and the B column. I think they're not different. That's my null, and we'll reject it or not. and with a 5% significance level. And here we go. So now I have my two variables. Now notice the t statistic this time is the same. So the t for when you assume unequal variances is the same number. So the t doesn't change, but the critical value does. So, so the number we would have to get to say there was a significance difference is now slightly higher. If the variances were much different, it would be much higher. So this number got a little bit bigger, and so this number did, but not by much. So we still are 59% chance that this was random, so we would fail to reject that these two groups have a different mean. We couldn't reject it, so we have no evidence that these means are different. So that is the separate variance t-test. So it's the same. You perform the same action as the pooled variance t-test, only now your critical values will be slightly different. All right, and in part B we will do one-way ANOVA.